Let me tell you about security, computer science, and information sharing platform. Security is the ability of storing a secret on a machine and protecting so that no one that is not authorized can access that secret. So it's really important if we define the our ability of keeping a secret as the basic of living organism on the planet, then protecting secret is very, very important. And usually we store a secret by encrypting it. Encryption does not provide any security. It's just translating a problem from keeping secret data close into like a safe box into it's transforming the problem into keeping the keys somewhere else. So you put the data in a box, you lock it up with the pad and keys, and then you need to store the keys in a safer place. And so it's translating the problem, it simplifies it for sure. Instead of having a big set of data to protect, then you have to protect only a key. So we do protection, security, by moving the security problem of a big security problem into a smaller security problem, but we don't solve it. And so we know how to protect data by protecting keys. How do you protect keys? So what we do is that we keep the keys secret, meaning that we don't store the keys anywhere. So a key in cryptography is like a secret code, like a password. It's something you only yourself know. And so if you're the only one knowing yourself, you will be the only one accessing the data. If you share that secret with someone, then there will be two persons accessing that data. And so on. So if you want to be able to keep a key secret, like a little code secret, and you want to be able to share that secret with all the recipients of the data that you want to protect. And in that sense, the problem of security is translated into how to safely share a secret. And you want to share a secret with people that you know who they are. So you translate the problem of keeping a secret into authenticating people so that you can send them the right secret. So how do you authenticate people? Basically, you ask their secret. You ask to prove who they are, meaning you have to pre-establish a relationship with them, and this relationship will define the trust level that you have with those person, and they will share some secret within that relationship. Those shared secrets are the keys to authenticate later in the future time. And so basically, usually what we do is we record a part of those shared secrets, and we don't encrypt them because then we'll have to have another secret to decrypt them. But we use what we call it hashing function. Hashing function is one-way function. Is that you can go in one direction. Basically, with a secret, you generate a code, but you cannot go back. So it's one way. It's like when you do painting, you mix two colors, you obtain another color, but you don't know the original colors. You cannot retrieve the original color with the final color. You mix like green and blue. So if it's additive colors, it will become in cyan color. Or if you get red and green, is yellow for additive color. And so, but you might have all different shades. And so once the color is mixed, you cannot re-identify the original color that were mixed. And so that's a hashing type of function, is that you change the information so that it's impossible to go back. So you use that a set of secret that you extract some secret from previous relationship communication, and you store a hash version of it. And when you say hash, it's like we can chop. It's like chopping a piece of the information, but not enough to retrieve the total. It's like you take a sample that does not reveal the whole set of the whole secret, and then you ask. Authentication is the asking of the secret and rehashing and compared to the hash version you stored. And if you have the same hash function, basically a hash function is unique for every secret. And so, I mean, might be collision, but a cryptographic hash is when the probability of collision is so low that it would never happen in the whole course of your life, in universe lifetime. And so by hashing secret, you can ask the same secret to the person you want to authenticate. And if the hash is the same, then boom, you know that's the right person. The major problem that it has is that by storing a hash, you leak information in a sense that you leak the information that with a secret you can test it's a right one or it's a false one. So it's a zero proof, that's what we call zero proof way of knowing that the secret is correct. But the information secret is correct, secret is not correct, is a form of information that you leak by storing the hash. And it's exploited by using brute force attack. Basically, you have a dictionary of all possible secrets, and then you just run through the test. Is the hash of all those secrets in that dictionary correct or not correct? And so that's the way we attack basically more or less all authentication system. And so how to secure that? Well, the problem is simple. If you guarantee that you never store a hash of a secret on any system, then you created an authentication system that cannot be attacked by brute force. And so how to make a security system? So we say securing the data is made by encryption. Encryption moves the problem of protecting the data, keeping data secret into keeping a key secret. And so the problem from encryption is moved to the problem of authentication. Authentication is fragile to brute force attack. And if we set the rules that we do not store any hash of any secret on the system, then we mitigate the attack, the brute force attack. We render those attacks impossible. And so we're crafting a system where you log in, you authenticate yourself, and any password, because we don't have stored hash, we don't know if the password is correct or not correct. So that means any single password landing you on the login accounts. So it's like, you have those anonymous email box where you create your temporary email, ephemeral emails, where you just log in with an email, no passcode, and then here is the mailbox. And so it's like one time email. And those, there is no wrong email. All emails are okay. And so the same thing is that if you create a system when you log in, you authenticate yourself, so username, password, boom, you end up on an account, temporary accounts. All accounts exist, all accounts are okay. And then you don't see the difference between the wrong one and the good one, beside the content that you previously stored. And so when you log in, you ended up, like if you define the space of the information you know by a membrane between what you know and what you don't know. And when you log in with what you know, password, and you land inside the sphere of what you know. If you log in with the wrong password, meaning you use a password that you believe you know, you land into a bubble in what you believe you know. And so you have not gained any new knowledge. You have not entered a new secret zone. You have not established a communication, a relationship with a new sphere of knowledge. So you stayed who you are with what you know, and you have not gained any information. So the secret kept into the protected knowledge has not been revealed to you, has not leaked to you. So there is no way to brute force, to break in that secret knowledge. So it's very important, is that it's the economy of knowledge, is that you exchange shared secret with people that you want to share knowledge with. And so in a platform where you control all the information that define you, you control all the information that you want to share, the act of sharing information with someone is the act of sharing a key that protects that knowledge. By sharing a key that protects that knowledge, you expose the inside the what you know to someone else. By sharing that what you know with someone else, create a new what the group knows and create this new entity, this new identity that defines what we know versus what we don't know. And so by having the ability to give access to your knowledge to people you want to collaborate with, to people you want to associate with, you create something first that is bigger than yourself, that is the merge of the knowledge that all living individuals hold. And there is a guarantee of protection as long as you keep your life secrets for yourself. So in a system where everyone has true, authentic secret that never revealed to anyone, that allow them to share secrets with other people, you need to have an infinite source of secret. And that might be the thing of life, is that you have the one that you hold for yourself, and you have all the other secrets that you generate to be able to authenticate relationship that you have. Life is nothing else than the ability of generating secrets, share secrets with one another. So on your digital side, your digital identity, your digital life is your ability of generating infinite secrets for sharing with one another. And that's exactly the key exchange protocols that provide this capability. Basically, with your own authentic secret, you can generate any new secrets that are derived from that authentic secret. But because of hashing, you protect that authentic secret. So you're the only one able to generate the other secret that you can share along the way, allowing you to enable collaboration, enable sharing of your knowledge, creating new digital form of life that are greater than yourself in an infinite way, still without compromising your true authentic self. It's a little bit tricky, but with diagram you might understand better.